My name is Zachary Howard, and me, along with my teammates, in our senior capstone project for Jacksonville University, we partnered with RepOne Strength to develop a digital weight leg extension machine. As you can see here, it's primarily made of steel, so it's a pretty durable machine, and it offers a more customizable workout experience for the user, as well as gathers data analytics and some different modes that help increase the efficiency of working out.
Hello everybody, so this is the power system / resistance module. This was designed with the intention of being as compact as possible, but also provide all the functionality that's needed to make sure this product works at its most optimal levels.
Hello everyone, my name is Zachary Lynott II. I am the designer of the resistance system for the RepOne leg extension machine. So for our design, we allow the user to actually select a weight range from 10 to 210 pounds. Now, unlike traditional leg extension machines, you actually, in a traditional one, you have to select the weight using a pin system and weight. While here, since we're only using a brushless DC motor to provide that torque, we simply have a slider for the user to interact with in 5-pound increments. And so now that the user has a set weight that they want to work out with, in this case being 75-pound force, the user can go ahead and engage in the workout, and simply all they have to do is grasp both of the present switches at the same time. And now that force is applied and the user can continue to work out. And when the user lets go of the present switches, either one, the resistance is disapplied and the reps are stored into a set, and all that data is collected. So going into the metrics that are collected during the workout, here, of course, some essential metrics that needs to be collected for any gym user is, of course, reps and the sets. Also records the last rep time as well as last set time, including watts, which is in power, and velocity in meters per second, of course, the range of motion that is used by the user. So the user actually has 3 different modes that they can play around with that the leg extension allows. Now these 3 different modes activate the quadricep muscles in different ways. So the mode that I was using previously is the static torque mode. Now, unlike a traditional leg extension machine, this can provide a resistance throughout the entire movement of the workout. So traditional leg extension machines, they provide a kind of a curve where it starts not at the selected weight but builds up to it till the 45-degree mark and then goes back down, while this provides that same resistance throughout the entire workout. And then here, a check mark allows you to actually enable that traditional leg extension machine feel where it actually does apply that curve, except this time that set resistance, that peak resistance, is actually applied at the 60-degree mark according to our research, where that's where the quadricep muscle is at its strongest. Now for our next mode is the concentric and eccentric mode, where it allows the concentric resistance, the lifting phase, and the eccentric resistance, the lowering phase, to be interchangeably changed, allowing the user to have custom settings where they can change how the force is applied when lifting and lowering, and allowing the user to have this freedom of the customizability for the workout. This can dynamically change how the quadricep muscles is developed, allowing for much higher precision of the development of the quadricep muscles. And so when activating the concentric and eccentric mode, you can tell that a load is applied during the eccentric resistance during the lowering phase simply by just looking at the workout. So when this force is applied, the resistance will activate when lowering down. Allowing the user to have much more freedom when working out.